The topic of correlation, also known as line of best fit and linear regression, involves data, and the data are plotted on a scatter plot. So you'll notice this graph is called a scatter plot because the data are essentially scattered across the coordinate grid, in this case, the first quadrant. Any individual point, as you can see, actually has two values. So if we look at any one point, that point actually has the value of, in this scenario, 6 hours and approximately a score of 85-ish. So all these data are two values in one. Now, when we plot them on a coordinate grid, we can see that a trend emerges. And we could say there's a correlation, not necessarily a causation. We can talk about that, correlation versus causation. But there's a correlation in this case that results in a positive result, meaning as the hours of studying increases, the test scores increase. That's why we have what's called positive correlation. There's also a negative correlation, which also, if you are keen enough to observe, can relate to the type of slope that the line that is created looks like. So this is a negative correlation. As the hours of television watches increases, the test score decreases. So there's correlation. We're not going to make a strong statement like it's a causation, as in watching television causes your scores to decrease. There are other mitigating factors that might influence that, but there is a correlation. There is what's called no correlation, and there is something called a constant correlation, which would essentially mean that no matter what happens, everything is pretty much the same height. Sorry, the same value. We could use height as a general example. As your age increases at a certain point, when you're mature enough, between 20 and whatever, your height is pretty much going to be in the same general range. It's not like there are 20 feet people and 2 feet people. Everyone's pretty much in the same general range. It's kind of a constant. And there are different strengths to your correlation. You'll notice that this and this are both positive, but the difference is this data are much more tight than this data are and this data are. So they're positive, but the strength at which they're close to the line is different. It's sort of more scattered, if you will. So we can talk about how strong that is by a thing called R squared, or the correlation coefficient. Correlation coefficient, or the R squared, can be calculated in your calculator or a graphing calculator. The closer this number is to 1, the more perfect it is. If it's 1, if it's exactly 1, it's perfect. If it's 0, it's essentially no correlation. And there could be somewhere in between, as indicated by these values. Once our data are graphed on a scatter plot, we can draw in a thing called the line of best fit. Now, the line of best fit is an approximation of what the general trend is. And we can eyeball it. There's a way to specifically calculate it. But using this line, we can now use this to make predictions. And that's ultimately what the goal of data is to make prediction and predict the future. So this line of best fit, which is somewhere in between, somewhere high and below some of the data, says based on the line of best fit, which is this red line, how many pizzas were sold if $260 were earned. So we go to $260. 260 is right around here. If we trace 260 over to the line, we could bring that straight down. So on this line, if there were a data point right there, 260 would correlate to about 40, so it'd be choice D. Other things we could look at with this line of best fit, you'll notice that's a positive slope. You could also generally assume, since it crosses the y-axis at around 0, the y-intercept would be 0. So if you're given a multiple choice question, you could try to figure out the line of best fit based on approximately, is it a positive or is it a negative slope, and then round about where it crosses the y-axis. So you determine your positive or negative slope and your y-intercept based on the scaling on the y-axis, and we could approximate it if that were the question and you didn't have access to a graphing calculator. Now, if you do have access to a graphing calculator, you actually can calculate the specific y equals mx plus b for a line of best fit. I'll show you how to do that in both Desmos and in a TI graphing calculator. If we're going to calculate the line of best fit using Desmos, the first thing we have to do is give Desmos our data. To do so, you have to tell it both the x and y, correlating the corresponding values, making sure that the x and the y are with its corresponding coordinate, its value. Otherwise, if it's out of whack, there's more x's than more y's, they're not matched up, you're not going to have the correct line of best fit. So in order to give the values to Desmos, first you need to insert a table. We're going to hit the plus button in the top left corner. We're going to insert a table. You will notice that a table by default shows up of x1 and y1. That's kind of what we want. If it's x2 and y2, it's not a big deal. You just click, hit backspace, change it to a 1, change them both to a 1. Remember that your independent variables are x's and the dependent variables are y's. You'll plug them all in. So actually showing you what this might look like in Desmos, I'm going to add this. I'm going to scroll down to table. You'll see them show up. So you can manually type them all in. Type in 2, 7, or whatever your values are. You'll notice that when you do that, a corresponding coordinate will show up. So when you're done, you will have all the points plotted. You could essentially take a screen grab of this if you wanted to. It also does a nice thing called zoom fit where it will graph it for you. So let me plug my values in and we'll check back. I have my values now plugged into my table. Sort of made these up. You'll notice that by the default screen, the default window, you don't see any of my points. But if I hit this little plus button again, it zoom fits it. So when I click this, you'll see that it sort of changed the scaling on the X and Y axis and also pushed it mostly into the first quadrant so you can see my line. Doesn't kind of look the way it should be because you notice that the scaling on the X axis is going by 5s and this is actually going by 20s. So it looks a little bit different than it really should. That's okay. Now, the next step, if you wanted to, you could label the axes. Like let's say we had X1 was time and Y1 was salary. You could always click on the wrench and just like we've done before with changing the degrees to radians or degrees, we could add a label. We can call this time in seconds and we could call this height in centimeters, whatever you're potentially measuring. You'll notice that the labels do show up if you want to take a screen grab and have it properly labeled. Now, to calculate the line of best fit, here's the key that you have to know. You have to tell Desmos, essentially you're going to give it the code to figure out what you want. And here's what you have to know. You'll type in Y1, so it knows that you're using the Y1 column. You're then going to use the tilde button, which is above the tab button. It's the little squiggly line, so hit shift and then that one, Y1 tilde. And then we're going to type in what looks like this slope-intercept form, y equals mx plus b, except we're going to use a instead of m. So it's going to be a x1 plus b. Now this is telling it to give me use this. It's not y equals mx plus b. If I typed in y equals mx plus b, that really means nothing. This is the code telling it to calculate the slope, a, which goes in front of the x, and the y-intercept, b. So now you'll notice my slope-intercept form is y equals, I'll type in what the slope is. We'll round to the nearest hundredths place, 1.32 x plus my y-intercept, 14.59. Now, it's not going to be exact, but it's pretty darn close. This blue line, which is going over the top of the line on best fit, it's close because I rounded, but that is now my line of best fit. I could use this line to make predictions. Let's say I wanted to know, if my x were now 20, where should it approximately be? You could see sort of on the line, 20 is around 41-ish. So if I typed in 20, you could use Desmos or whatever, plugging in value 1 to 1.32 times my x, which is now 20, plus 14.59. You'll notice it's around, like we said, 41. So you could use a line of best fit to make predictions. You could reverse it if you had your y. Let's say we want to know how much time it would take to get to 60. You would, of course, plug in 60 for y, and then you'd have to solve that equation by using inverse operations to solve for your x. Once you have this, it's the same with if you use the graphing calculator to do this, but I'll show you how to calculate the line of best fit with your graphing calculator in a second. Before I go too far, you will notice that we do have my correlation coefficient here, my R squared, which is 0.8996. Pretty darn close to 1, so I'd say it's a strong positive correlation. To do the same process in a graphing calculator, TI graphing calculator, you're first going to need to input your data. So you will hit Stat, Edit, type in your values into list 1, list 2. Got to be careful, make sure you're using list 1 and list 2. If those got deleted for some reason, you have to bring them back. If you want to clear out that list, make sure you go up to the L1 and hit clear, not delete. That's how you delete a list. So you'll hit clear, scroll back down, everything will be gone. Same thing with list 2. Type in your values. Type it in, enter, type it in, enter. If you want to see the picture of the scatter plot that Desmos showed us, you'll need to go to second Y. You'll go to stat plot. So you go to plot 1, turn it on, make sure you choose a scatter plot, and you want your list to be list 1 and list 2, obviously. You can choose the size of the pictures you want. Hit enter, then you'll hit zoom 9, zoom stat, and it will show you the graph. That's not really as much of a concern. More so is calculating the line of best fit like we did with Desmos by using Y1 tilde. We're going to do the same thing with a graphing calculator by doing stat. So same thing we did to edit, but this time we're going to scroll over to calc. We'll go down to linreg, which is the same y equals ax plus b or mx plus b that we did. Make sure it's choosing list 1, list 2, y1. So by default, it's that, but you want to type it in. List 1 is, I'll show you where that is on the graphing calculator, but it's the blue part over the 1. There's list 2 if you want to use those, and you'll do y1. So it will now give us, once you run this linreg, you might have to hit enter a couple times. You'll see that again, it reminds you it's y equals ax plus b. So a is the value that goes right here, and b is the value that goes right there. It does give us our r squared. So using this, since a was 11.73, that value goes as the coefficient of x, and the b, the 193, that would go as my y-intercept. We could use this now to make predictions if we needed to. If you wanted to graph the line of best fit, you'd have to type that in by doing y equals and type that in. So let me show you by using a graphing calculator how that would work. Again, here's your graphing calculator. You would hit stat. You would have to edit, so we'd hit 1, and type in my values into list 1, list 2. If I already have values in here, don't hit delete. I'm going to scroll up by using the D-pad to list 1. I will hit clear. You'll notice that the numbers are still here. We have to scroll back down, and now they're all gone. Once I type in my data for list 1 and list 2, I would hit stat again, go over to calc, and this time I want to run linreg. So I could hit 4, or I could scroll down to 4 and then hit enter. It's by default in this particular version of TI-84. Already says list 1, list 2. This is what we want. I would have to hit enter a couple times. Now, when I do this, it's going to have an error because I didn't put any values into my 2 lists, which we knew was going to happen. But you could see what would come up are the values we need to write my equation, and then I could use that equation to make predictions. So now how could I actually do this from beginning to end if this were a multiple choice question? Using the equation of line of best fit, which is not given, so I obviously need to calculate it, which number is the best prediction for the output, aka my y, when the input, aka my x, is 13. So basically it's saying if x were 13, use the line of best fit to find what my y would be. Now I don't have the line of best fit. I had to calculate it by plugging all of my x's into list 1, or my x if I'm using Desmos, and all of my y's into y or list 2 if I'm using TI. When I do that, I will get an A and I will get a B. Now the A and the B that I'm given will help me create an equation. So I'll do it real quick and I'll show you what the values actually were. So I typed the data into a table in Desmos. Did the same thing, a table into my list 1, list 2, and my TI. In Desmos, you'll notice that doesn't really look good on the graph, so I have my zoom fit. You can see the whole thing. I've already typed in y1 tilde ax1 plus b, so you'll see it's calculated my r squared, which is pretty strong, and my a and my b. So it's really the equation y equals, around to the hundredths place again, 9.79x plus 42.95. You'll see that the green line sort of corresponds to the black line of best fit. We'll get these same values by doing TI, using the TI-84 in this case. We'll again hit stat. I'll scroll over to calc. I want to do linreg, so I'll hit 4. Has all my values. I'll hit enter a couple of times. You'll see that again, it gave me the same A and B. Could use these values to now make a prediction. So using this equation, I could plug in for x is 13. So I would plug in just simply here, I would do 9.79, I believe it was, times 13, and then plus, what was my value? 42.95. 42.95. We'll see there's approximately 170, which is the choice. Choice is C. Again, you would plug this in. You'd see what your A and your B is, and this is just straight up asking you for the line of best fit. If they give you a picture, you don't even necessarily have to use your graphing calculator, because if I approximate my line of best fit, I first notice that my slope is negative. So this question, this choice, which has a positive slope, can't possibly be the answer. The next thing I'll look at is, where does it approximately cross? Now, if you notice, it crosses positively around a positive 37. So my y-intercept is a positive 37, not a negative 37. So my answer is choice A, without actually having to figure out what all these data and what they all represent, each x and y, and plugging it in, although you could if you wanted to.